Hello everyone and welcome. We are in the CFI village and this is the next conference, Hacking Operational Technology. I'm pleased to welcome Remco Hoeksman, who will present this presentation.
Okay, very well.
Give it up for him.
Yeah, thank you. Very warm welcome here. Let me first introduce myself. My name is Remco Huisman. You already did that, but I now pronounce it in Dutch. It's a typical Dutch name. And you see here, I've been working in cybersecurity for over 20 years. I'm not a hardcore technician, but in all those years, I know a lot about it. And before we start, who of you is really technical? Can I show some hands? I see 1, 2, 3, 4. So the other ones are not that technical. I think it's going to be a right mix, I guess, about explaining more about operational technology, but also showing what more in-depth stuff. You see this OT hack box standing beside me. Normally, I can do some of these attacks that I will show you in real life on this system, but in this crowd, in this setting, that's too difficult to do. So we made some movies of these attacks, but if you want to see them, you can come to booth DT02 to see them in real life. I can actually do them there if you want to. So then you see Secura and you see Bureau Veritas. I've been working for Secura for over 20 years, and Secura is part of Bureau Veritas, providing cybersecurity services. So what do we do? Just one slide, 20 seconds about what we do. So we do audit and risk assessments, we provide security training, people security testing and certification services. And so that's very short. I like to tell you more about it, but let's do that on the booth on D22 because we're going to need the time. Operational technology. There are a lot of definitions about operational technology. I'm not going to, you can read them, but what you basically must understand is that it are devices or things that can actually do something in the real world. So like open a gate, open a sluice, turn on a valve, or do stuff in the physical world, you might say. So industrial control systems, that's where ICS stands for, are cyber physical systems. And there are also kinds of systems. There are also networking systems involved, but you have to think about, for example, actuators, sensors, and stuff like that. So this is a typical setup of a factory, for example. In this case, it is a dam producing energy, and there is a physical process. There are things really happening. And where it is controlled, that's the operational technology part, right? Or the industrial control systems. And it's a lot of IT in there. So it's not only about only operational technology, but it's also IT stuff that you find there. So it's Windows servers, switches, everything like that. And it is connected. Some people say, well, it's our IT environment is not connected with our operational technology environment, but in most cases that is not true, because there's always information needed on the OT side that's coming from the IT side. And most attacks actually also start in the IT side and then go over to the OT side. That's where the phishing takes place in the IT side, for example. And you can also, for example, in the OT part, you can leave devices behind that get access to the network. Because most of the attacks that I will show you today will originate from inside the network, where an attacker already has, through phishing or devices that are left behind in this network. So a bit of alphabet soup. There's a lot of terminology about operational technology. Also SCADA is being used, or ICS. And you see PLCs, that's actually a thing here that you can control and program, and a lot of safety stuff as well. So who can tell me sectors where industrial control systems are present? Anyone? Where do you have operational technology? Well, it's everywhere. It's in mining, it's in oil and gas, in water, manufacturing, nuclear, everything, everywhere where there needs to be done something automatically done in the real world. And these are all these sectors. But there are more of them that you might not even be aware of. Like in infrastructure, if you going through a tunnel, for example, you see those signs, or it's controlling the access to the tunnel, for example, or measuring air quality in buildings, for example, or in transportation. It's everywhere. On ships, you can't escape from it. And a lot of these systems are part of the critical infrastructure that we depend upon, like, for example, electricity, drinking water, transportation. There is all, there is OT used. But it's not always of critical infrastructure. That's determined by the government and especially also by the European Union, if it's critical infrastructure or not. So there is this NIS directive that you have to report, for example, cyber incidents. You have to take appropriate measures to protect against cyber attacks because countries depend on it. You can cripple a country by taking down the critical infrastructure. And now we're getting the NIS2 directive, and it gets even more important. The governments are putting more emphasis on cybersecurity through the use of and the implementation of the NIS2 directive. And it is even so that CEOs of companies can be personally liable if you do not have proper cybersecurity in place. So I'll try it again, some interaction with the audience. Who can name some differences between IT and OT? What's the main difference? Well, I will tell you, the most important difference is that from IT, you want the information to remain confidential. That's the most important thing mostly. But in operational technology, you want it to work. It must operate correctly, but it must work. So that's the prime directive for operational technology. But it's a bit more complex than that, because there are all kinds of systems that are intertwined, and IT and OT are not that easily separated. And one important thing of operational technology is the fact that attacks on operational technology may have an impact in the physical world. For example, I get to that later on, but if you can, like, say, stop an alarm from happening or stop a ventilation thing from starting in a control loop, then you can overheat things and a reaction might actually explode. For example, in a nuclear energy sector or in a regular or in a chemical plant, you can actually do physical harm with these attacks. And there are examples of that as well. So, any real OT cyber attack, yeah, you know one? Yeah, I can't read, it is too, but anyway. Okay. Well, the very first one was Stuxnet. I don't know if you heard Stuxnet. It's very famous, it's quite old, but it really was the first. That was where, I think, well, allegedly, the US and the Israelis destroyed nuclear centrifuges in Iran by using malware. So that was basically the first one. And that was actually a so-called air-gapped system. So there were no connections. So they used a USB stick to distribute the malware. But there were many more examples later on. And most known one is also the attack in Ukraine. Not recent ones, but the past ones, because there were some wars before. But there are many cyber incidents, and also recently on ICS systems. I get back to, for example, there was this Florida water plant that got hacked. You had the Colonial Pipeline in the United States, for example. You had meat producer, GBS, that got hacked. And there are so many examples about it. Okay, so we're now getting into the hacky stuff, really. But first, let me explain a bit about this. We call it the OT hack box. So it's basically a control loop where you have. I can more easily explain it here. So you have the switch, you have the PLC. That's a programmable unit. You have an HMI. There is an alarm. There is a ventilator that turns on when the temperature rises above a certain level. And when we started here this morning, it was 18 degrees. It's now 25, so it's kind of hot in here, but you may have noticed already. So this temperature this sensor measures the temperature. It provides this to the PLC. You can show the values on the HMI. When the temperature gets too hot, the vent starts blowing, and if it's really too hot, then the alarm will go off. Yeah, that's the alarm. And in a system like this, there are several layers that you want to try to keep separate. So on the lowest level, you have those sensors, and on the highest level, you have, for example, Windows PCs of operators programming this device. So there's also some stuff on the back. So we use a Raspberry Pi for interpreting the data, and we have a little network device called a NUC that's running some virtual machines on Windows, so we can access them and run them. So if you take this system, then you here have the layers where we can do the attacks on. And I'm going to show 4 of these attacks to you if time permits. I will start with an attack on the switch, because if you have the switch, you can do all kinds of nice stuff. The second one, it's the HMI, because in order to control that HMI, I don't have to press the buttons. I don't have to be physically present. There are other ways to control it. An engineering workstation we can do very difficult attack on the PLC itself, but why not hack the Windows system that an operator is using, and we do the attack from there, right? That's a lot easier. And the fourth attack will be on the PLC itself, where we will influence what the temperature sensor is saying to the system. So these are the attacks. And the fifth one, there's no time for that. Okay, attack on the switch. So there are a lot of industrial switches out there, and they can have all kinds of shapes and forms, and they're everywhere in the system. If you take, for example, an offshore wind turbine, for example, there are a couple of switches in there. There are switches everywhere. And they're often poorly configured or even unmanaged. Well, you say, well, why should I protect it? I just put it in there, it works, I plug it in, I use it out of the box, and that is quite okay. Because if you want to control them, you don't have to go to the switch or plug something in, really. You can be on the network, and it has a web interface. So you can just browse to the switch and do whatever you want with the switch. Or you use SNMP to configure it remotely. And that's very convenient, of course. But the web interface, when it comes out of the box, it has weak credentials. So they're weak or default, and people don't change them. So if you're into network, you can access the switch. And the same goes for SNMP, right? So that's a problem. So if you want to attack that, you just see a company video, for example. You look at the internet, you see some demonstration, then you see, oh, well, this is this type of switch. Then you will download, for example, the user manual of it. And there you can read that the default password is credentials are admin and private. That's very strong, right? Could be admin, could be admin, or well, whatever. You're nodding. You know it, but you know how it works, right? So, but when you do that, then you actually, yeah, don't recognize that when an attacker is in the network, he can easily do an attack on the switch. And if you have the switch, then you can do lots of things. You can stop it. You can tap on every network traffic. You can, well, basically do whatever you want. So, what would be the mitigations for that? For example, know what's on your system. Know all these switches. You're aware that you have all these switches, because that's not like a switch is something very stupid or easy thing. Well, it's just a component. You put it in there. You need it to connect all the stuff. So why bother doing something with it? But you need to know that it's there, and disable unused services on it. So does it need a web interface? Do you need to remotely configure it? And if you do, then change the default credentials, right? That's quite simple. Okay, the second attack is on the HMI. And HMIs are everywhere. They kind of all, it now looks like this, but when you see that whole wall over there, that's also an HMI. And it can be, yeah, you find it everywhere. And also, they're also accessible from the internet. Like the attack in Florida on the drinking water facility, that was just an HMI interface that was accessible from the internet. It was just open and plain on the internet. Somebody could access it and then change the chlorine levels of the water, right? So that's what I thought. And it was also used, and I think it's important. Sometimes you think hacks are very difficult, but it was also used in the Ukraine attack. Just get access to a panel like that, but then virtually, and then you can do whatever you want with the system. And that is being used a lot. So, but now we're getting a bit more technical, because if you're on a network, then you first have to know that there is an HMI. So you use a program called Nmap that basically scans the network and finds everything that's out there on the network, right? So if you find it, then you know where it's running, and then again, you can use another program that's called Wireshark. You can use it to sniff the network traffic, and you can see the challenge and response for the when you log into for the credentials. When somebody logs in, then a request goes to the HMI, and then you enter your password, and then it gets entered into the HMI, and that's network traffic. And that network traffic you can sniff, and although it is encrypted, it can be decrypted. You can break that, and the default password length of an HMIs are like in the old days, and not that old, and like the old days are always present, because these are mostly old systems. Like modern HMIs or whatever, they have good protection and good encryption, but like the older ones, they don't. So you have a 7-character password, you can like crack that almost instantly. So we use that, and then you can push buttons whatever you want. So we have this little movie about it, where you can see that. So you can do everything with like, you can control everything with the HMI. So you can set the set points, you can override the alarm. So it's especially important if you change, for example, the alarm value and the vent value. If you lower it, well, then the alarm goes off. But if you want to do harm, then you put it on higher. So what can we do about it? Stronger credentials, of course. Use better protection. And also evaluate, do you need this remote access to it? In most cases, yes, you do. Because, for example, if you have a substation on sea converting power of wind turbines, then, well, you need remote access. If like the HMIs in a factory where you don't want to be because it's hot, it's dusty, it's dangerous, then yes, you need it. But lots of times you don't need it. So then disable remote access. And if you can't disable remote access, then you can segment your network, right? That's something you can do. An attack on the engineering workstation, then. That's quite an interesting one. So they use it to program PLCs, but also for maintenance if something is malfunctioning and you need it. So an engineering workstation can do with a PLC whatever he wants. He can brick it, he can change values, he can do everything. So if you really want to do something, it's very easy to hack an engineering workstation. And an engineering workstation is basically mostly a Windows laptop or PC, whatever. And those version that you use to access the PLC, the software of the vendor is bound to that PLC, so it's not easily upgraded. And also because it's running a specific version, it's not always easily to update Windows. So you're running older versions of Windows on an engineering workstation. And well, is that bad? Yeah, that could be very bad. It's certainly not a good idea. We come across a lot of Windows XP systems nowadays even, so they're quite vulnerable. So how does an attack gonna work? First, you're gonna need Nmap again to look at network and find engineering workstations. And yes, we can find a Windows 10 workstation there. You see that in red. And if we drill a bit further down, then you know what kind of build it is or what exactly the version that it is. And then you know if it's vulnerable or not. You can look that up on the internet. And in this case, it's vulnerable for Eternal Blue. And Eternal Blue, it's actually a vulnerability where NSA developed an exploit for it to attack systems without people knowing it. And it has been used for a very, very long time before they had to inform Microsoft that this vulnerability was actually in there. So please keep in mind that although systems, you have your system patched to the newest level, for nation states, it mostly is still vulnerable because they know exploits and stuff that people don't know yet. But yeah, there was a patch out, but yeah, well, as I explained before, you can't, it's not easily patchable because then your system will not work anymore. So, well, then you take the decision, well, let's live with a vulnerable system. It's not that bad, right? Unless you get an attacker in your network. So, if you want to attack that system, we use a tooling called Metasploit to actually attack that system. I won't go into that too deeply, but then we can actually use to get malware installed on that system, and then you get a command and control over that system, and then we can basically do whatever we want with the system. So a little movie about that, what you can do with it. So we already took all the steps and we're now on the engineering workstation. And then we can find, we can browse through the things that are running on the workstation, and we find this PLC that is running there. We're downloading like the information from it. And you can see on top of there that it is in remote program mode. So you can put these things also physically in many cases in a different mode. So and then an attack like this won't work. So you're loading the variables. That's actually the logic that we are now loading into that system. So here you see all the switches. For example, these switches that are here that can do the alarm on. You can see the physical values here as well. You can turn, the fan turns on, the alarm turns off, the set points, it's all in there. If you can override it, then it doesn't work anymore. So that's what we do with an attack like that. And if you change that, you override the physical value, then the alarm won't go off anymore. And that's actually dangerous, of course, in a setting like that. So, what can we do about it? Well, I already explained patch management, keep the system up to date, but that's difficult or expensive or whatever. You don't want to do that. So you could also disable services that are not needed. So SMB-v1, that is something that you shouldn't be using anymore. Or like, for example, if it's a system using Telnet or whatever others, you don't want to be using that anymore. But also disable remote management functionality. If a system doesn't need to be remotely operated that often or programmed, just disable that. And if you really need to do something with it, have it enabled in a service window, for example, and then this risk is really mitigated. Yeah? So, the last attack that I will show you.
Just by the way, Remco, you have like 3 minutes. If you want to add just a little Q&A part, then keep in mind.
Okay, shall I? Okay. Yeah, well, then I skip this one. If you want to see the Modbus flooding attack, which is actually nice, but yeah, well, we don't have time for it. Please come visit me at the booth D22. But I want to conclude with a slide that you. I showed a lot of techie stuff, but it's not like cybersecurity. It's not all about technology, right? You really have to do something in the people and process and technology side of things. So you have to train people to be sensitive about like programming a PLC, keeping systems up to date, make it impossible to reprogram them, use good credentials, don't use default credentials, all kinds of stuff. But also do have good processes, for example. If you look at technology, have monitoring installed, do penetration testing, yeah, really do something with it. And as we are Veritas and Secura, we can help you answer all these questions and build a roadmap to raise your cyber resilience in operational technology and information technology. Floor is yours.
Now, the interesting part, also the active part for you. What are your questions? We know the first one is always the most difficult one, but let's go. You can ask any questions you want to Remco. What questions?
And if you don't want, it's also fine, right? So look me up. You don't have to. You may.
You can ask anything if you want.
No questions?
Yes.
Oh, hey.
Thanks for your presentation. You talked about network segmentation. Can you explain how that works in practice on OT?
Well, for example, you can make separate VLANs to make like less, to make it more difficult. Like VLANs is not the holy grail, but you can make it more difficult. You could install firewalls like filtering Modbus traffic, for example, or yeah, there are all kinds of things you might do. You can also, there are also intrusion detection systems of vendors that are out here like Forescout and Nozomi, for example, or yeah, you could do all kinds of things. Yeah.
Yeah, thank you very much for the presentation. If an intruder is already in your OT environment, how do you detect them? What's the regular procedures? In IT, you have the managed detection and response, but in OT, how do you understand that somebody's on your premises?
Yeah, it's a lot. Yeah, it's more difficult, but there are solutions for example, of the vendors I just mentioned, and there are more of them, for example, and there are also some services like doing endpoint detection on certain devices that is also possible. So that these are some measures that you can take, and sometimes you can also like do. If you don't want to invest that heavily in those kind of measures, like a Modbus flooding attack is very clearly visible in a network, for example. So you can do your own detection on that, for example. Yeah.
A last question. Okay, thank you very much, Remco. We can give a hand for your presentation. Thank you.
Thank you. Yeah, it was a pleasure.
And have a good day.